Hello, let's talk about data structures. Think of data as groceries, you hold it in a bag. Structure is how the bag is organized. What kind of bag it is, like cover or a cloth bag or a basket. The properties is to hold the groceries. When we say data structure, we are talking about both what we are holding it and also how we are organizing it. In simple words, a data structure is just a way to store and organize data so we can use it efficiently. It's like arranging your wardrobes. Shirts in one drawer, socks goes into another drawer, right? It's similar to that. Some structures here are super flexible and some are more strict, but each one has a purpose here. Python gives us some handy data structures like lists. It holds strings, numbers, and other lists, and the properties are whatever the data it holds, it holds orderly, and once it's created, it can be changed, and also it allows duplicates, random insertion, and deletion. Lists are like baskets. You can put whatever you want and rearrange them whenever you want. Dictionaries. It holds key value pairs and it has unique key properties, and also values are accessed with the help of keys. The best example for dictionary is the post box. If you know the post box number, you can collect the post, right? Similar to that. Sets. It only keeps unique stuffs, no duplicates are allowed. And then tuple. It also holds similar to lists like strings, numbers, other lists, and it exhibits the properties of unchangeable lists. That means once it's created, we can't be edit. Lists are like baskets. You can put any items and rearrange them whenever you want. Dictionaries are like labeled drawers. You know what is inside and you can pull it out quickly with the help of keys. Sets are like sticker collections. You can only collect unique stickers. No duplicates are allowed. Tuples are like frozen arrangements. Once it is set, we can't edit. These arrays, lists, stacks, and dictionaries are optimized, fast, and easy to use, but sometimes they are not just enough. Suppose if you want to build a patient monitoring system, a dictionary is enough to store and retrieve data very quickly. But what if you want to create an appointment wait list? Daily patient activities representing hospital organizational hierarchy, relationship between patients, doctors, rooms, and devices. So, in order to maintain all those things, then we need to use user defined data structure. These are our own customized tools to organize and manage data based on your needs. So, if you use only the array, list, tags, and dictionaries, we can't do multiple things in a single data structure. Imagine these boxes are the stack of containers, kindly of like a stack of plates in your kitchen. You can only add or remove a plate from the top. That's exactly how a stack works in programming. So there are two main operations here, push and pop. First I'll push the number 10. It goes into the first box, then I push 20, 30, and finally 40. Now all four boxes are filled and 40 is at the top of the stack, right? So now if I want to do a pop operation, I remove 40, the last item which I have added. That's the key idea. Stack follow the last in first out principle. If I pop again, I remove 30, keep popping. Eventually the stack will be empty. So stacks are super useful when you need to keep track of things in reverse order, like undo operations, browser history, or even evaluating expressions in your codes. Next comes queues. Now think of waiting in line at a coffee shop. The first person who is in the line is the first one to be served, right? That's the queue concept, or a first in, first out, we can say. So there are two options here. There are two operations, sorry, here NQ and DQ. NQ is nothing but entering the queue, and DQ is leaving from the queue. So queues are great for printing jobs, task scheduling, or customer service systems. Let's talk about linked list now. Linked list is a sequence of nodes where each node contains two parts. The first is data, means the actual value we want to store, and the next one is address. Address is means a location of the next node, where the next node is present. So that memory location will be stored in the previous node address. So here in our example, we have three nodes storing the values 10, 20, and 30. Each node points to the next one using its address. The first node is called the head of the node, and the last node is the tail of the node, which usually points to null in a single linked list. In this example, the first node holds the address of the next node, and the next node holds the address of the last node. So the traversal is one way here only from head node to the trail node. In doubly linked list, consider the same nodes, but only the difference is each node has data and the address. In the address field, it stores the previous node address as well as the next node address as well. So that's why it's considered as a two-way traversal. So it can traverse from head to tail node and also tail to head node. Circular linked list. As the name suggests circular, it also holds circular functionality. Means the last node usually has the null pointer, right? In the previous examples. But here it holds the address of the next node. So this 30th node holds the address of the 10th node. So that's why it formed a loop. Tree data structures. A tree is made up of nodes connected by edges. Here in this example, A is the root node. It's the starting point of the tree. See, nodes are like D, E, F, S that don't have any children, so that's why it's called leaf nodes. Nodes like B and C are intermediate nodes, so they connect to the root to the leaves. This structure helps us organize data in a way that reflects relationships and hierarchy. So consider the restaurant's menu example. So imagine this menu is structured like this. The root node is the restaurant menu, starters, mains, desserts are the intermediate nodes, and then salad, soup, pasta, pizza are all the leaf nodes. Correct? So they don't have any subcategories, right? The leaf nodes are doesn't have any subcategories. This tree structure makes it easy to navigate the menu and organize items logically. So the use case of tree structures are like file systems or databases or routing algorithm. In these fields, tree structures are used. Graphs. Graph is also made up of nodes. Nodes is also called vertices, which represents entities. And also it is made up of edges, which builds the relationship between two nodes. There are three types of graphs: unidirected, directed, and weighted graph. Consider the unidirected graph. So here edges have no directions. So if node Alice is also relation with Bob, Bob is also in relation with Alice. So there is a bidirectional relationship between each nodes. In directed graph, edges have a direction, so which is shown in arrows. So a connection between Alice and Bob is there, but there is no connection between Bob and Alice here. And similarly, Alice and Charlie, but there is no connection between Charlie and Alice. Weighted graph, which assigns a value or cost to each edge. These weights can represent distance, time, cost, or any metric. But in this example, so there is a weight which is a kilometer or a distance. So edges between cities have weights representing travel distance or time. So based on that, our direction will be different. Heaps. Heaps is a special kind of binary tree used mainly for priority management. Heap is completely binary tree that satisfies the heap property, which has two types: min heap and max heap. In the min heap, the parent node is always less or equal to its children. In a max heap, the parent node is always greater than or equal to its children. In the shown example, in considering min heap, so the first node, which is 2, which is lesser than the next node, right? 3 and 4. So it is in the increasing order. When we consider the max heap, the first node is 100 and then it is going on decreasing, so it's called a max heap. I hope you got a basic idea of what each data structure does. So there are a lot more to learn in each data structure. So that's why we'll do a separate video of considering a single data structure and do some Python coding. Then we can understand clearly each data structure. Thank you for watching.